ladies and gentlemen. Welcome back. Section 9.3. We're already halfway through chapter 9. How neat is that? I love this time of year. We're going to solve quadratic equations by graphing. It's not that big a deal. In fact, with using Desmos like I'm going to show you in this video, it's laughably easy at some points. So this will be quick. I want you to be able to locate the solution to a quadratic equation on the graph. We'll do that using Desmos. We'll have to do a little bit of algebraic manipulation, and we're going to do some word problems. Stop it. You'll be fine. What's a quadratic equation? This is a quadratic equation. Ax squared plus bx plus c equals 0. We've been dealing with these quadratic trinomials for a while, and we factored them and we graphed them when they were f of x or y equals ax squared plus bx plus c. Well, now we got rid of the y, we got rid of the f of x, and we have an equals 0. So we have to figure out what value or values for x will make this equation equal 0. Now, with a graph, our definition of a quadratic is, the definition of a solution to a quadratic function is where the parabola crosses the x-axis. Here, I'm going to pause, write that down. We're looking for where it crosses the x-axis. Pause or unpause. If we have a parabola, we're looking for these 2 points, right? These 2 points where the parabola crosses the x-axis. Now, it's possible that your parabola will not touch in 2 spots, right? Most of them will, but you might have a parabola that kind of comes down and then stops right here at the line, then bounces back up. That would have one solution. You might see 1 or 2 of those. And you might even see one that doesn't touch it at all. And if it never crosses the x-axis, we'd say that it has no solution, okay? Can't tell you how many of those you will or won't see, but they might come up, okay? Most of them, though, you're expecting 2 solutions, one here and one there, okay? I'll probably show you some examples of the other ones real quick before we leave. The solution for a quadratic equation goes by many names. The solution is the big one, but it also gets called the x-intercept or the x-intercepts. We also tend to refer to them as zeros. Find the zeros because this is where y equals 0. See, we got rid of the y, we replaced it with 0. We really just plug 0 in for y, okay? So sometimes we'll call these the zeros. And then also kind of the old school way to talk about these is we call them roots. I don't use it too much, but it's one of those things where like you won't hear it, then all of a sudden an SAT problem will be like, find the roots of this parabola. And you're like, huh? It's all of this. It's all different ways to say these 2 points, the x-intercepts, points where across the x-axis, okay? Get down that vocab, and then we'll do a few of these examples. How do we solve these? We do it by clicking on the solution. It's really easy. I'll show you. Okay, so sorry for that weird little interlude here, but we're getting wild. So I've got Desmos open here now. You can see that. I'm trying to find a good spot for my head. That'll work. And if I click this home button, this is kind of be like a home zoom spot for us. And so I've got x squared plus 8x plus 7 equals 0, and I want to solve this by graphing, okay? And to solve this by graphing, I'm just going to type in x squared plus 8x plus 7. And look, there's my parabola. And if you look real close, you see there's these 2 little gray dots right on the x-intercept. Guess what those are? They're the solutions. When I said all you do is click on them, I meant it. All you do is click on them. What are my solutions? My solutions are x equals -7. It's right there. And x equals -1. Oh, snap. It's right there. And that's all you got to write down. Like you just write down those 2 things. That's solving by graphing. Desmos makes this too easy. I'm not going to lie to you guys. Like of all the things we've had to do on Desmos, finding the solution shouldn't be this easy. Now, granted, if we're using the TI-84s in regular class, it's not that much more difficult, but you don't just click them. But that's all you got to do. That's all you do. You just click them, okay? Let's try another one. Pause the video if you want. Try it on your own. Otherwise, you come over to Desmos, 2x squared minus x, minus 3. There we go. And look at, there's another parabola. And there's a solution. X equals -1. X equals 1.5. Ta-da! I want to make it hard, but I can't. Okay, I can make it hard. I can always make it harder, but the basic of it is right here, okay? Now, they'll give you one like this. Ruh-roh. Hi, Scooby. You guys probably know who Scooby-Doo is, but whatever. Maybe you do. He's kind of having a resurgence. Anyway, now I've got x squared plus 5x equals 14. And what you probably, hopefully, have noticed is all of these have always been equal to 0. And that's important, right? Because otherwise we don't really, I mean, okay, it's a quadratic equation still, but for us to solve it, we need to get it equal to 0. So I need to take what I've got here, and instead of having it be equal 14, I need to move that 14 over to this side. Now, I mentioned briefly earlier, we're going to have some algebraic manipulation. Here it is. I got to subtract 14 from both sides. 14 minus 14 equals 0. And then I just get x squared plus 5x minus 14, because none of these are like terms, so they can't combine. So it is what it is, right? It just stays where it is. Once I'm here, type it in. Nothing changes. X squared plus 5x minus 14 equals 0 when x is negative 7 and when x is 2. Those are the two values that would make this true. And understand that's what we're finding out, right? If we plug negative 7 into this original equation, we get 49 plus negative 35, which comes out to 14. You can check my math. I dare you. Same thing happens if I plug in 2. 2 is a little easier to check. 2 squared is 4, plus 5 times 2 is 10. 4 plus 10 is 14, right? You can always check your answers on these just by plugging them in. But that's what we're doing, right? We're just finding the values of x that make this whole thing equal 0, which would make this original equation true. Always our definition of a solution. Nothing changes, okay? Now, like I said, I can always make it harder with a word problem. For the record, that took way too long to put together, so I hope you appreciated it. It's fine, right? It's a word problem, so how's it work? Words, culturally sensitive nicknames, physics, words, yes, all the applications for quadratics usually have to do with physics. And then there's going to be a big old fat equation slapped somewhere in the middle of it. It's always going to look something like this. H equals negative 16x squared plus some number times x plus some other number. I could tell you what the 75 represents. It's the initial velocity. I could tell you what the 6 stands for. It's the initial height. It's great if you want to go into STEM one day. If you're just trying to get through your math class, I still love you. And you just type the equation into Desmos and answer the questions it's going to have about the parabola, because it's going to have a few more words and then it's going to have some questions. So if we look at this example and we just type in, negative 16x squared plus 75x plus 6, you'll see a whole, big, long, scary looking graph. It looks like it doesn't really stop if you go up the top. So you'll probably have to click on graph settings and change your Y range down here. I don't know, try like 200 or something. Try that out, see how that works if your numpad's not turned off like mine is. Hold on. Hey. And then when I skip out of it, look, I can see the top. And if I want to zoom in a little more, I can. I'm just using my wheel right now. But the questions it's going to ask you is it's going to say, what's the maximum height the ball reaches? And so you just click on the maximum. You remember those from the other video, right? And the maximum height, I just clicked on the vertex. It's right there. So maximum height is the maximum value. It's the y of the vertex. It's k. So I would just write 93.9 because I think it says nearest 10th. If it says 100th, go to 2 decimal places. You can figure that out. If it asks you how long does it take to get to the maximum height, well, that's the x value of the vertex, because the x is always going to be time. We've talked about this in word problems before. Don't let it scare you, okay? So your time it takes to get to the maximum height's here, your maximum height's there. It'll also ask how long it takes to hit the ground, which is when it's back to 0, it's just a solution. Again, guys, word problems are just ways to cover up the regular math we've been doing for the whole chapter. So if the first 8 problems are easy, the last 2 aren't harder because there's word problems. You just have to do what it's telling you to do, which is the same thing you've been doing. So you're going to have to find the vertex. You're going to have to find usually just the right solution. The left solution is going to be at negative time, which is not helpful. So that's usually what you'll be looking for. Okay. All right. That's all I got. If you have questions, you know where to get a hold of me. Otherwise, thanks for watching. I tried to keep this under 5 minutes. I'm pretty sure I'm over, but you know what? I still love you. Thanks, guys. We'll catch you next time.